Hey people, thank you so much. Welcome back. And in this topic, we'll talk about the practical versus statistical approach. So you already know by now that in Six Sigma, we try to solve the problem, and Six Sigma is a statistical approach to solve the business problem. But before we go for the statistical number, we need to understand what business problem we are trying to solve. So when you receive any of the business problem, that business problem is basically your practical problem. And this practical problem, we try to convert into some number, because in Six Sigma simply we say, if you cannot measure, you cannot control. So problem must be represented by some numbers, that how big is your problem. Once you convert that problem into the business problem, which is the practical problem, which you need to convert into the statistical problem, then you develop a model, process characterization, and find it out that how you can provide the statistical solution for the statistical problem. So once you identify the practical problem, you will convert this into the statistical problem. Then you will try to find out a statistical solution for that, and those statistical solution you will be implementing practically. That will be your practical solution. Let's take an example. Suppose today your CEO comes to you and he says, okay, Mr. Black Belt or Miss Black Belt, that you have to improve let's say, employee satisfaction score. My employee satisfaction score is low. So improving the employee satisfaction score is your practical problem. But how you are measuring, what you are doing with this employee satisfaction score, you don't have anything to know about. You are not aware employee satisfaction score. So when you convert this practical problem employee satisfaction score into the statistical problem, so what you will be doing, you need to understand that what is the scale, what is the definition of employee satisfaction score. The definition is that, suppose this is the well-being of employees. This is the well-being of the employee within the organization. Now, what is the scale you are using? Let's say you are using a scale of 1 to 8. What is the current performance of employee satisfaction score? Maybe your average value, let's say 3.25. What is your minimum target or minimum expectation? You will say minimum expectation is 5 for the employee satisfaction score. So how much is the gap you have from the target to the current value? Target to current value is 5 minus 3.25. 1.75 is the gap which you need to fill. If you convert that, how much effort you have to make to fill this gap, which means the gap percentage. So gap percentage will be your difference divided by the baseline, 3.25. So which is around 53% gap you have to fill. When you represent in this way, like as well-being of the employee, you have to improve on a scale of 1 to 8, where the current value is 3.25 against the minimum target of 5. So you have to improve it by 1.75 point, which is, if you are moving from 3.25 to 5, this will be around 53% improvement in your business. That is called your statistical problem. And these are the statistical numbers. So practical problem was employee satisfaction score. When you are representing it in numbers, with the scale, with the target, with the current value, with the performance expectation, with the difference, then this is called a statistical number, as a statistical problem. Now, the next thing will be to find out the statistical solution. So what we'll be doing here in a statistical solution, we will try to develop the process characterization of the data by following the equation y is equal to f of x. Y is equal to f of x means output here. Y is equal to your output. And what is the output? Output is employee satisfaction score. Must have some relationship with the process. F is equal to function, the way you are operating the business, or maybe because of some of the input variable that is contributing to your low employee satisfaction score. So you will be molding this equation. Try to find out maybe x value may be, like, as most of the people must be thinking about, salary is the one of the factor, learning and development is the another factor, maybe like as recreation activities is the another factor, manager behavior is the another factor, the environment is the another factor, the location is the another factor, and so many things are there. So all these things you will be molding and characterizing to achieve the maximum output, which is the y variable. On this 5 you need to achieve. That will be your statistical solution. So whatever the x value you are trying to identify, once you implement all those practically, that will become your practical solution. So what you will do practical solution? Okay, let's say employees are complaining about the recreation. So develop a recreation room. People are talking about that the probably the, let's say, the parks are low. So let's increase the parks if it is possible to you. Maybe the engagement activity are not there. So let's increase the engagement activities for the employees. And there are many more things will come which you will be implementing practically. So this is the basically the process to continue any Lean and Six Sigma project. First, we understand practical problem. Then we convert this practical problem into a statistical problem. Then we find out the statistical solution of that. And finally, this statistical solution, we identify characterization and the optimization of the process. We implement that practically. That's about the how the Lean and Six Sigma will approach. So when we follow this entire process, the methodology we follow in Lean Six Sigma is your DMAC methodology. And what is the strategy working behind this methodology? Strategy is y is equal to f of x, which means y, output variable, is a function of your input variable. If you are optimizing your input variable, then definitely your y variable will be optimized. Thank you so much, people, and I will see you in the next session.